We will be discussing the problem in Pytle's book at page 85, number 2.80. The figure shows one half of a universal coupling known as the hook joint. The coupling is acted on by the three couples shown. A. The input couple consisting of forces of magnitude P. B. The output couple C sub O. And C. The couple formed by bearing reactions of magnitude R if the resultant of these couples is 0. Compute R and C sub O for P equals 600 Newton. First, we identify the given and the unknowns. Then, we transform all of the forces at its vector form. Then, we need to find the couple that exists between the forces of P. Since both the forces exists at the z-axis only, if we are to analyze it, we can see that the couple exists in the x-axis since the moment is parallel to the z-axis, and the forces are parallel to the y-axis. Therefore, we just multiply P with R to get the couple of P, which is 108,000 Newton-meter. Since we know that we have two unknowns, we need to establish two equations. Since we are given with couples, we can only establish moment equations. Now, we already know that the couple in respect with P is 108,000 Newton-meter. We now need to know the couple that exists between the two forces R. In order to get that, we need to identify the equation of small r through the distance of the two forces. As we can see that the distance of the two forces R in the x-axis is equal to 60 cosine 30 degrees. While in the z-axis is negative 60 sine 30 degrees. To get the equation for the couple with respect to R, we need to get the cross product of the small r and the force R in which we get this equation. Even if we try to use the other force R as a reference, we will still get this equation for the couple. Then, let's express the couple C sub O in its vector form. Now that we already know the couples, the only thing left to do is to establish the moment equations. As we can see, through the couples, the only axes that exists with the moment are the x and z axes. So we can only establish moment equation with respect to x and z axes. Establishing the moment equation with respect to x, we can see that we need another equation for us to be able to solve for the unknown. So we proceed with the moment equation with respect to z. Now that we have two equations, we can now solve for the two unknowns, which are force R is equal to 1800 Newton, since it is moving further from us, and C sub O is equal to 187,064 Newton-meter. Reminder: we need to achieve one of the following conditions for us to be able to have a moment at the x-axis. One of the following conditions must be achieved for us to have a moment at the y-axis. For the moment at the z-axis we need to achieve any of these conditions.